Hello, good day. This is Dr. Cool with a Fix. Today, I'm going to be addressing the question why most variable compressors fail. As you can see, I'm holding one of the variable displacement compressor shafts in my hands. And when this compressor works, that works very great. You often sometimes don't even know that the compressor has kicked on because it has a very low input of engaging the compressor to the engine, so it doesn't really dramatically change your engine sound instantly. So because of that, a lot of people actually do have this mindset that it saves more fuel compared to the old system of compressor, which is a fixed displacement compressor that is currently and fastly phasing out. If you're new to my channel, kindly subscribe to my channel. If you've done that, sit back and let's get to it. I think the reality in this that lies within a fixed displacement compressor is the same reality that is often emphasized most often times about manual transmission system. So that's why in Africa, fixed displacement compressor is also described as manual compressor. Why? Because you can hand pump it. You can pump it manually to know if it is still working or if it has failed. Why? The variable displacement compressor is called automatic compressor. Then within the variable displacement compressor, there is still a variable displacement compressor that have a clutch to it. So they're also called that one automatic manual because it has a clutch and it has a solenoid control. Just like this one here for Mercedes ML350. You can see the solenoid that's attached to it. And most often times when this compressor fails, it is not like the fixed displacement compressor, which in most cases is technicians' miscalculation or error that often ruin it. Now, in the case of a variable displacement compressor, most times technicians might get their calculation right, but just a little bit of mess, just a little bit of mistake, just a little bit, uh, you know, not carefulness, or maybe the shaft of the variable displacement compressor didn't act properly. That is what results into most failures of variable displacement compressor. But over the years of fixing car AC, I actually realized that the variable displacement compressor is not engineered to last long, just like the automatic transmission system. In a case of automatic transmission system, there is something that comes to mind. Automatic transmission. We talk about the fluid that it uses, it's special. We talk about the solenoid control valve. It is special, just the same way. So now in the case of fixed displacement, it doesn't have a special features like that. Special features that is meant to create a special problem to take a special money out of the special customer's pocket. So everything goes special, and that is why it fails. It doesn't. Some of them have clutch, but it's not about a clutch. So it fails because of some reasons. The first reason, like I named, is mechanical failure, which is some sort of a structural failure. When the shaft inside loses its alignment for any reason, for just any fraction raising, then the entire system will be in the jeopardy, just like the one I am working on currently, which is ML350. That system has ruined a lot of compressors, and the more you get it in. So what I'm trying to say here is, when there is a dirt inside the system, which is the second thing, is going to ruin it. But how do you even prevent those dirt when you can be so sure that the piston inside can align properly? Because this piston often wobbles and play around most often times, and they are not precise in their movement comparison to a fixed displacement compressor, where there is a guide to how the pistons move. But in the variable displacement compressors, as it varies, the piston tend to shift and go off the direction that it's supposed to be moving, and when that happens, it starts scraping the walls of the compressor cylinders. What I mean cylinder is not actually the cylinder where the piston fits in. It is more like the bell housing of the compressor. Thank you. I'm gonna be using that. I borrowed that word right there. The bell housing, which is the one you're seeing right in front of me there, not the solenoid valve I'm holding right now. The bell housing is where the shaft seal, the compressor shaft seal, is attached to. Right? So that bell housing, when it starts scraping the wall, that is where it started introducing dirt into the system. And when it started introducing dirt into the system, based on how this thing tilts, the shafts tilt in order to be able to create a variability in the system, in the variable displacement system, in order to cool properly based on the command input it receives from the ECU. Now that is where the first nightmare will begin with. Now in the case of this case study of Mercedes ML or some other Mercedes, I've seen this a lot. So it doesn't relate dirt, it doesn't relate any little debris, even though you can see it. As soon as you get into the solenoid electronic control valve, it's done. You get it stocked closed, and as soon as you get it stocked closed, now with the solenoid, the clutch still engaged and the system is still pumping refrigerant, the next phase that's going to be dealing with, in as much as the discharge section has been shut off, and that discharge section that is often shut off is being controlled by the electronic control valve. As soon as it's being shut off, there is no any refrigerant that's going to be going through the discharge pipe. And when that doesn't go out of the discharge pipe again, what happened? They act against the pressure plate, the valve plate that is at the back of the compressor. And when that happens, the system automatically stops cooling, and that is when you start having your system blowing warm air. So like I said in the context of this video, that the variable displacement compressor is not built to last. It's just like every other part, but in this one it fails more very often. On a scale of 1 to 10, you're gonna sail like 6, 7. It fails so rapidly compared to fixed displacement. Fixed displacement, on a scale of 1 to 10, you're gonna be seeing like 1. All right, and what I'm saying here is the fixed displacement has a tendency to tolerate dirt, debris, and if the oil get blackened, no problem. If there is iron filing that is being chipped off, that is being chipped into the system, maybe by some sort of a mechanical parts error or some sort of things like that, the compressor doesn't get knocked out. Why? Because the discharge section, the discharge line of that compressor is still very active, and those minor debris that is being left inside the system is not strong enough to actually block anything, because there is no any electronic control solenoid valve right there, and therefore those particles will move from point A to point B and back to A again without creating any harm inside the system. Some of these microparticles can even scale through the metering device without even causing any obstruction. So when we look at the design features of the fixed displacement compressor, it is much more rugged. It is nearly that, I mean, it can actually die. And most of the manufacturers, automotive industries who are building this, they knew it quite well, just the same way they knew that the manual transmission system is not a problematic, and therefore they have to opt for something that's going to be giving them much more money. That's the reality right there. That's the reality. Now, a lot of you might be arguing about this or try to hit me on this, but this is the realest truth you can ever hear from any mechanic tell you. The more the variable displacement compressor fails, like here where I'm working right here, I have about 5 of variable displacement compressor that fails, and they have just one thing that failed within them before the system started turning into shit, and that is the electronic control valve. That's the thing. So here, when your variable displacement compressor fails inside any system, if it is not the solenoid that fails, you are on a grace. You are on a set of grace. But if suppose it is a mechanical failure, maybe the piston creates any debris inside the system, or the piston knocked out, maybe broken because of any mechanical error, maybe the shaft misaligned or tightened fast based on the inputs command that the computer gave it, your saving that AC system chance is like, on a scale of 1 to 10, is like 2%. Your ability to be able to save it as a mechanic or maybe as an enthusiast is like 2, except if you are to be replacing the entire system. When I mean entire system, I mean including the evaporator. And now you know exactly how much that's gonna cost. And that doesn't end there. If you replace the entire system and you miscalculated the amount of oil that's going to be inside the system, I'm saying this in respect of some other car makes such as Hyundai, Kia, and you miscalculated the amount of oil that's supposed to be inside the system, or the oil didn't circulate enough to get back to the compressor and lubricate the system while the refrigerant is being pumped, then guess what? The compressor is still going to be knocked out. So you're going to end up keep buying one compressor after another. So to me, the design feature of the variable displacement compressor is a disaster. Seriously. When I've actually compared the cooling capacity between it and some other fixed displacement, and literally, sometimes I don't actually think there is much of a difference. If there's going to be any much of a difference, it's going to be like maybe 10% or even 5% different. That the fixed displacement has more cooling tendency of 5% different, but not in all cases. I've seen some other cars that the fixed displacement cools much more better. So this thing I'm holding right here is a nightmare that fail most oftentimes, and it's been caused by that. For some manufacturers who knows what they're doing, they engineer a filter to cover that suction area of that solenoid valve right there, so that no matter the amount of grimes and debris that get formed inside the system, when the piston start acting up, it shouldn't affect it. So with that said, I hope this help you to fizzle out the problem with your car. I hope this help you. And if it does, subscribe to my channel, share with your friends, give me a thumbs up, and drop me a message of thanks on the comment section of this video. And I gotta catch you guys later. This is Dr. Quarterface. Bye for now.